Welcome to homework.
Triangle is considered the strongest geometrical figure in terms of construction. Why? Let's look at an example. The obvious next level structure you can build after a triangle would be a rectangle. Instead of using 3 sticks, you would use 4 sticks. Now, what happens if you apply a shear force on on this kind of a rectangle, which is bolted at these 4 common corners? Now, first of all, what is a shear force? A shear force is a kind of force where it applies something like this. So it's kind of a twisting force. You need not have two forces. You can simply forget this. And let's say if this is on the ground where these two are fixed. Now, if you apply this force, that is also a shear. This is very similar to what would happen if you come running and then stop on a rug. You would you would pull the rug along with you forward. It's some force like that. Now, if you apply the shear force on this would very easily turn into a parallelogram. Now, that is not acceptable in many buildings. You simply can't have walls that are bendy or floors that are shaky. So that is why a triangle is better. Now, if the 3 corners of triangle are fixed, any shear force you apply won't change its shape. That is why triangles are amazing. Now, I'm going to go further and give you a even more rigorous mathematical explanation. So if you don't understand what is following, it's fine. The answer that you have heard until now is good enough. But if you are mathematically inclined, you should pay attention to this. Why does triangle, why is it that this triangle, one of the simplest possible structures, the strongest? The answer is if you are building structures with straight rods, let's say, the first closed figure you can build is a triangle. The simplest structure that is not closed would be a single rod. The simplest structure that is not closed after the one single rod would be 2 rods, either connected at some point or not connected. This is useless anyway, so we'll only consider this. But if you add one more rod, that's a closed figure. And that's perfect. Now, if you add one more rod and create a rectangle, what you're doing is, now this structure has one extra freedom of motion. That is why when shear force is applied, it is very easy for this to bend. And triangle, being the simplest possible figure, does not have any other freedoms of motion. So when you apply force, it simply breaks or just holds position. If you apply strong enough force, you can break it. But if your triangle is strong enough, it can never change its shape. So you might be asking a question, but this doesn't seem right. A more complex figure you would expect would provide a better security. It does. If you remember Eiffel Tower or some other such giant iron structures, you'll remember that they don't use these rectangles, but they use these rectangles with X's on them. What this does is, now these 6 rods together with these 5 joints are just like a triangle. When a shear force is applied on them, these don't change shape either. And this is in fact one of the most commonly used structural parts in most buildings. When you want some parallel structures, this is what you go with, because building parallel structures with triangles is a little hard. You would have to go something like this. Whereas with these, you can, these are basically just triangles with an extra layering. So that is it. Yeah, that is another good point, actually. You can think of this as just a mixture of 4 triangles. One triangle over here, one triangle over here, one triangle over here, and one triangle over here. So even in this case, triangle is indeed the basic structure, which is the strongest.